In the last lesson, we looked at calculating simple interest, which has to do with borrowing or investing money. There's something else called compound interest that we're going to look at today, and it works a little bit differently, and you're going to see whether compound interest would work better if you are borrowing money, or would it work better if you were investing money. Let's go back to just our equation of this is our simple interest equation that we used in our last lesson. Interest equals the principal times the rate times the time. So I'm going to show you how compound interest works differently from simple interest. So to do that, we're just going to use the simple interest equation that we learned in the last lesson. So what is the total amount of money in an account where $600 is invested? We learned that that is the principal. The principal is what you invest or what you borrow. At an interest rate, here's our rate, and we always convert that to a decimal by moving the decimal 2 places to the left. So that would be 875 ten-thousandths. Compounded annually for 2 years. Here's the time. Now, this is not simple interest, so we cannot just plug these numbers into our simple interest equation to find the answer. So what we're going to do is we're going to use the simple interest equation, but we have to do it 1 year at a time. So our time is just going to be 1 year, and then we can't do 2 years at a time with this particular equation. So let's find the amount in the account after 1 year. So back to our simple interest equation. Interest equals the principal times the rate that we converted into a decimal, and we're just doing it for 1 year. So I know it asked for 2, but we're doing 1 year at a time. To find the interest and just multiplying 600 times 875 ten-thousandths, you will find out that the amount of interest in the account after 1 year is $52.50. So how much is now in the account? Remember that the initial deposit was $600. After a year, you earned $52.50. So if we add those two together, we can find out how much is in his account now, and that would be $652.50. Now here is how compound interest is different. For the next year, for the second year, we are not going to base our interest off the original principal of $600. For year 2, you're going to earn the interest based on how much was in the account after the first year. So the principal has now gone up. If this was simple interest, you stick with the $600 per year for however many years. But with compound, each year the principal gets more and more and more. So now when we figure out the second year, we have to start with the principal that was in the account after 1 year, which was $652.50. We multiply it times the percentage rate of 0.0875. Now, let me just show you something really fast. I could have gone $652.50 and multiplied it times the percentage rate, and that would show us how much interest was earned, but then we have to go back and add it back to the principal. To make this a one-step equation, to eliminate that one step, if you will put a 1 in front of the rate, the decimal that we used for the rate, what this does is that means that you are doing, this stands for 100% of this. So it's saying, yes, I have all of this in the account after 1 year, plus I have this much more. So here's your principal, here's the amount of interest, and you can add them together. This is a way to add those together, but do it in one step. All I had to do was once I converted my rate into a percent, which was right here, I put that 1 in front of the decimal, 1 and 875 ten-thousandths. That means 100% of the principal. Now when I multiply that together, it's going to tell me that I now have in my account $709.59. Had I not put the 1 in front of it, I would have multiplied this number times this number. I would have got the amount of interest, and then I would have added that amount of interest to the $652.50 and got this number. But I eliminated that step by simply putting a 1 in front of the decimal. So now, after 2 years, there is $709.59. If this had been simple interest and not compound interest, for the second year, we would have used $600 right here, and you would have earned less interest. With compound interest, you're earning more. You're making more money. So if you're investing, compound interest is going to be great. If you're paying, you don't want to have to pay more as time goes by, so do not use compound interest when borrowing money. Now, we actually have an equation that we can use because let's say you're compounding interest for 6 years. You don't want to have to go through the steps for year 1 and then go through the steps for year 2 and then go through the steps to... How about if we use an equation so you can do it all in one step? Here is the equation that we used for compound interest. So on your notes, you want to circle this, you want to highlight it, you want to write it down. Here's what we're going to use. Let's see what it means. I still stands for the amount of interest, just like we had up here. P still stands for principal, like we had up here. Here is the rate, like we had up here. Notice we put a 1 in front of a decimal. That means we're going to have 100% of what we invested plus the interest rate. Here is the T, like we had up here, but here is the difference. The T is an exponent. So it's the percentage times the rate with a 1 in front of it, and then the time becomes an exponent. This changes the way that we evaluate it. So we can do the same equation that we just did back on the previous slide where I showed you year by year, and instead of figuring out the first year and then figuring out the second year, we can do it all in one step by plugging into this equation. So let's look back again. Here is our principal. Here was our rate, but we converted it to a decimal. And here was our time. If we plug those into the equation, here's what it looks like. We're looking for the amount of interest. We plugged in the principal. We're multiplying that times the rate, but we put a 1 in front of that decimal. That means all of this plus the percentage rate. And then the 2 years is now an exponent. Now, here's where you have to follow your order of operations. This is very important. When solving this problem, you have to do exponents first. You do not do multiplication. You remember PEMDAS, parentheses, exponents, multiply and divide, add and subtract. Exponents come before multiplication. Here is the exponent you have to do first. The exponent 2 is attached to the percentage rate with a 1 in front of it. So you're going to take your calculator and you're going to go 1 and 875 ten-thousandths squared or raised to the second power. Push equals on your calculator. Once you find that number squared, now this may not be squared. If it's 3 years, this is going to be raised to the third power. If it's 4 years, it's going to be raised to the fourth power. And you use your little button on your calculator that looks like a rooftop to do that, and I can show you that in class how to do that. You put 1 and 875 ten-thousandths raised, push the little rooftop button to like the third power or the fourth power. This happens to be squared, and you have a squared button on your calculator. Once you do this first, you square that number first, then you're going to multiply it times 600. And we get the same answer, $709.59 that we did. Let me go back to the previous slide, that we got right here when we did the first year and then use that into the second year. But instead of doing it year by year, we can use this equation for a one-step process. So let's look at this again. Let's try another one. What is the total amount of money in the account where $5,000 is invested? That's your principal. Rate of 5%, convert to a decimal. Compounded tells me that I'm not using the simple interest. I'm using our new equation for compound interest for 3 years. So do you remember what that equation looked like? Okay? That equation was interest equals principal times the rate, but we put a 1 in front of that decimal, then the exponent is your time. Let's plug those numbers in here. Now, let me just show you what this would look like if you did it year by year by year. I'm not going to use the equation first. Let me back up. This would be the long way. If you were using this equation up here, let's just see what happens year by year by year. If we figured it for just 1 year, I don't have to multiply it times 1, but I put this 1 in front of it. This plus an interest rate of 5%, after 1 year you would have $5,250. For the second year, for the principal changes. You no longer use the $5,000, you use the $5,250. Multiply it times the same rate times 1 year. This is going to be year 2, but it's for the next year, so you multiply it times 1. Now in your account you have $5,512.50. So for the third year, you don't use this as your principal, you now use this as your principal. And so I use the $55,1250 and multiply it times the rate. And you would do that year after year after year. Now you have in your account $57.88.13. That's what would happen if you used your simple interest equation. When if you use that, you have to do 1 year at a time. Each time, whatever the amount was, that's your next principal. The new amount is your next principal that you plug into the equations. Or we can use our one-step method. So if we do that, our interest equals the principal was $5,000. Our rate was 5%. We put a 1 in front of it, which means all of this amount plus the interest rate. But it says for 3 years, so this time our exponent is 3. Remember, we have to do the exponent first. So it's how you type it into the calculator that's very important. So with your calculators, you are going to type in 1.05 raised to the third power. Look for the little rooftop button. That means 1 and 500ths times 1 and 500ths times 1 and 500ths. It's that number multiplied times itself 3 times. But if you use the button here on your calculator, it goes faster. Once you get that amount, then you're going to multiply it times the 5,000. And when you do that, and once you find out that you now have in your account $5,788.13. Now let me go back to the slide before. Remember, that was the same answer that we had right here after doing it year by year by year. So it shows you that that equation really works. If I'm going to figure out compound interest, if I use the simple interest equation, I have to do it year by year by year using the new amount for the principal each time. If I use this equation, I can do it in a one-step process, plugging it in. Once you plug in the numbers, make sure you always do the exponent first, 1 and 500ths raised to the third power, and then multiply it times 5,000, and that will give you the amount in the account. Okay, so try this on your paper and see how well you can do with it. Good luck.